Alright guys, today we're going to do synthetic division, and the first thing you can do is, if you printed out your notes, just read through this definition of polynomial division. And if you lose yourself in a little bit of the wording, let's just look at this formula right here, and we're going to look at it in respect to this note. The polynomial P is called the dividend, D is the divisor, so this is our divisor, Q is the quotient, R is the remainder. Now if this remainder equals 0, then we know that D is called a factor of the original polynomial P. Now, as in all other lessons, let's see when we actually put some numbers to these formulas and see how they work out. Before we can understand or actually respect synthetic division, we're going to learn to appreciate it first by doing long division. Now there are some times in which long division is better than synthetic division and vice versa, but we're going to show you a long division problem so that you can come to appreciate the beauty of synthetic division. Alright, so the first thing we want to do is we want to divide this polynomial by this. So I'm going to set this up, and I will have x cubed plus 4x squared minus 5x minus 14, and we want to divide this by x minus 2. Now, because this is two terms, we're going to say how many this divided into the first two terms. In the line of questioning that you ask, you say, this times what will give me this first term? So x times what will give me x cubed, and I would need two x's, so an x squared. Alright, and then after you determine what's up here, now you kind of like distribute back. You say x squared times x would be x cubed, and then you say x squared times minus 2 is minus 2x squared. And just like in a normal subtraction problem, the next thing you would do would be subtract that level. Well, since there's two terms, it's like subtracting, changing the signs of both of them. So change both signs. This goes away, and it should, if you got this part correct, this first term should cancel. And then 4 plus 2 is 6x squared. Alright, and then just like in division, we would bring the next term down, so minus 5x, and then we would start our process all over. Again, we would say this number, or this variable, times what gives us this. So we have this, and we're trying to get this. We need a 6, and we also need an x. Okay, once we determine what this is, then we distribute back. 6 times x is 6x squared. 6x times x. And then we would say 6x times negative 2 is negative 12x. And then change all the signs, because that's our subtract part. Cancels, which is good, because if it didn't cancel, I knew I made a mistake up here. Add down, and I would have 7x. Drop the next term. And then we start over. We ask ourselves, this times what gives us this first term? So for us to get from here to here, we need a 7. So I'm going to say plus 7. Once we determine what this is, distribute back. 7 times x is 7x. And then I say 7 times negative 2 is negative 14. Our subtraction step would have us change all the signs. And our remainder is 0. So this polynomial divided by x minus 2 is x squared plus 6x plus 7. Okay, I want you to take a few minutes in your notes that you printed out and read through this. The purpose of this is just to have step-by-step directions in case you get lost or stuck anywhere in the middle. Although synthetic division is a very easy thing to do, and don't let any of this confuse you or make it seem complicated. But when it says synthetic division has to be in the form x minus k, I'm going to flip back to the previous. This is x minus k, the known coefficient in this place is a known 1. If, for example, if that was like 3x minus 2 in the bottom, that's not in the form x minus k. We could not do synthetic division with something like that. We would have to use long division or do some work to synthetic division to change it into this nice format. So that's why I said in some cases long division works better and sometimes synthetic. But read through those. It's just very point blank step-by-step procedures. But the actual process is not hard at all. Okay, so the first thing we want to make sure that in this numerator our terms are in descending order. So x cubed, x squared, x, and then the constant term. If there are any missing terms, we need zeros as placeholders. There's nothing missing and they're all in order, so I'm going to drop the coefficients. The coefficient of this is a known 1. The coefficient of x squared term is a 4. The coefficient of this term is a -5, and then this is -14. Okay, so your first step in synthetic division is to make sure these are in descending order and that there's no missing terms. And then we're going to have a box over here, and if this is -2, it's going to be +2 in this box. And let me just take a minute to explain why, because if I was to set that equal to 0 and solve, we would find out that x equals 2 because we're looking for a 0 of the polynomial. So if it's a -2 here in this format, when you set up synthetic division, you do a +2. Okay, that you will do every time, and here starts our process. Always drop the first term. Always drop it. And then the process starts. 2 times 1 is 2, and you put it in the next slot. Add down. 4 plus 2 is 6. And then we start over. 2 times 6 is 12. You put it in the next position, and then you add down. And then you say 2 times 7 is 14. Add down. This becomes 0. This last column, put it in a box. This is your remainder box. Okay, so anytime you're dividing, if I had x cubed, a third degree polynomial on this one, and I divided one of the x's out, it makes sense that it's going to be 2 x's left, so it's always 1 degree less. If my original polynomial, the leading term is a third degree, my solution will always be 1 less, so this one's going to be an x squared. If it was an x to the 5th polynomial, my solution would start with x to the 4th. If it was an x to the 8th, when I drop down, it would be x to the 7th. It's always 1 degree less when we put it in our solution down here. So since this was an x to the 3rd, I start with x squared and just keep going descending until I can't go any further. So this is going to be x squared plus 6x plus 7 with no remainder. And I want you to look back. That's the exact same thing we got with the long division problem. X squared plus 6x plus 7. You can see it's a lot less time and a lot less, one more page over, a lot less time and work involved in using synthetic division. So that's the magic of it. Alright, let's do one more. We're going to check x cubed, x squared, x, no x, that's a constant, so it's in descending order. I'm going to drop my x coefficients. So 4, -15, 11, -10. Be careful to keep the signs with them. In the box, if this is a -3, we know over here we have a +3, and we're ready to start. Always drop the first. Multiply. 3 times 4 is 12. Now add down. -15 plus 12 is -3. Start over. 3 times -3 is -9. Add down. Start over. 3 times 2 is 6. Add down, we get -4. This is our remainder box. So we have a remainder this time, so let's see how that changes. Now, if this is a x third, our answer is going to start with x squared. and then we go down until it just stops. So we have 4x squared minus 3x plus 2. Now since this is a negative 4, I'm going to say minus 4 over the original. So that's how you represent when you have a remainder there.